Hello, and welcome to Lesson 7 of Learning Python. Today we're going to pick up where we left off in the last lesson with the Safe Hacker program. And we're going to extend it a little bit more. So first let's start by copying it to a new version. And we're going to go with something very simple. We're going to find out how long it takes the program to figure out a combination. So let's go with editing Safe Hacker 2, which right now is just an exact copy of Safe Hacker 1. But from here we're going to need another library, and we're going to have to use a bit of a shortcut to make it easier. The reason being is sometimes libraries can grow extremely long in name. So in order to actually time how long this is going to take, we need to import the datetime module or datetime library. This library provides a wide range of functions that cover just about anything you can imagine with dates and times, including being able to calculate how long a distance is between a starting date and an ending date. It's really a wonderful tool, but it can get quite lengthy as we work with it. For example, in its current state, we need date time dot date time dot now to give us the current date and time. As you can see, this is confusing and it's a lot of repetitive typing. So from this information, we can extend our import call to allow us to actually shorten this and only import the one function we want. But if we use other functions, then we have problems. But for now, we're just going to use from the library date time import only the function date time, which means now all we have to write is just date time dot now to get the current time. So let's actually put that into practice. So let's come down here. Now I don't want to track how long it takes to build the list. I can, but I don't want to. I want to start tracking the time here. So I want start time equals to date time now. Now this will give me the starting time in seconds. So we'll actually be able to use this information at the end of this to make a calculation to tell us how long it took at the end of the process. So once we find that we have completed the process, we want to know the ending time. We want to stop it as quickly as we can after we know we've succeeded. Again, we're going to use date, time, and the current time in seconds to get the ending. So now it's just a simple matter of subtracting the start time from the end time to give us how long it took to actually find our combination. So let's actually get into this. So now that we have that, we can say elapsed. Let's continue with the lowercase beginning. Elapsed time equals end time minus start time. Now, in the process of these variables, the one thing that I think stands out is you can use upper and lower case any way you want. And as you can see throughout this program, I'm using it in different ways. It really doesn't matter as long as your variable names are consistent from the beginning. For example, with number list, I started with a capital N. So every reference to it after that has to have a capital N. But with start time, I'm using a lower s, so every reference after that has to start with a lower s. Okay, so now we modify our line, and we're going to add one more twist to this. We're going to actually use what Python calls an F string, or specifically a formatted string. And that's done by putting the number or the letter F in front of the string, and then we simply put brackets around the variables. But this is one string. And we can also add it and make it sound better, read better, all of the things that took or that we want to take into account to make this look like proper English and something that is nice to look at as we develop the program. Now there's a lot of abilities that this does. And the nice thing about using an F string is Python can convert strings and numbers internally for display. And you can really do a lot of formatting and unique things with it for setting up columns and tables on the screen as you want to see your data. So it's something that is worthwhile understanding because it can really help produce very nice looking charts and data streams that will help you get information quicker and more efficiently. So for now, we have this simple process, and it should give us how many tries, how many counts, and the elapsed time. So let's get started, and let's see how well this works. Now we're using SafeHacker 2, and let's start with the rather large number. Let's go with 10,099,000 inclusive. And we see it took it 0.343005 milliseconds. Very, very fast. And it took 32,000 tries meaning 32,000 attempts in that list, but it only used 6,650 of our list. That's interesting. Now that seems a little confusing, and I probably need to rephrase that a little bit, but let's step this up. And as you can see, the formatting really looks nice. And notice how it automatically printed hours, minutes, and seconds for us. Okay, so now let's take and let's up this a little bit, and let's see how long this takes. Again, the phrasing needs to be reworded, but that's a visual matter, not a logic matter. Now this might take a few seconds or minutes. Let's see. So while this is going, let's talk about the process of how you would use this in a real-world situation. Specifically with trading, it's important to know how long a trade is going to take. Once you place the trade, meaning your algorithm has done the math and you are in the process of actually placing the order on the exchange, it is absolutely critical to keep that process as fast as possible to prevent price differences or slippage in the price. So having this kind of information is very critical. And in terms of what the program is demonstrating, that is an attempt of somebody trying to break into a computer. The longer the attack runs, the more likely it will be discovered. So from the standpoint of an attacker, knowing how long a process takes can help him or her decide how much of an attack to proceed at one time. And that's something that we're going to demonstrate next, is how to actually count and track progress. So let's bring up SafeHacker 2 again. In this particular situation, it found the result in 48 seconds. Okay. Okay, we actually need to just take this out. It's not the number of tries, it's the actual combination. So again, a visual obscurity, but something that can be confusing to any user using this program over time. Okay, but now let's take a real world situation, something that is dealt with all the time. Let's start up here with the combination. And let's actually move this down where it belongs. One of the biggest things that we face when dealing with data is not everything is going to take place in one session. When we're writing our trading program, it could take minutes, hours, days, or even a month to complete one single trade. Because of that, we need to be able to store information on disk. And that really is the last major component we need before we start building a trading bot. So here we have a simple process. We know the combination. But now, what happens if the program is interrupted? Well, it gets restarted and we end up losing that combination. So the first thing we need to do is set it up so that if the combination file doesn't exist, then we make a new combination. If the combination file does exist, then we simply read the combination. Well, Python has a way of doing that. And it's from the OS library. So let's come up here and import OS, or operating system functions. So if os.exists, and then we're going to give it the name of the file. So if this file exists, and this is provided by the library called OS, then we're going to read that number into the system. So if we already have a combination, we don't want to change it. So let's start with what's called a file handle. When you open a file in any programming language, and Python is no different, you're given a file handle, or you're given a variable that contains information about the file. That information is what is needed every time you want to work on a file, like adding information to it, reading information from it, or even just overwriting it. So if we need to have the system, have Python give us that information for future use. And now we need to have a special word in the language called open. And we're going to open the file name that we gave it above. But it needs to be in quotes. And now, in Python, there are special characters that open takes. Those characters are R for read, W for write, and a special character where you want to write to a file but you don't want to destroy the existing contents. A for append. Now you can easily go into a search engine and type Python open command example or Python file open example and get a large array of information on just how versatile this really is. But for now, we're just going to go with very simple, very easy stuff. So now that we have the file handle, now we can use this information to read the combination using the file handle, and it'd help if I type right, and read line. This is a special command built, or a special function from the file library, which is part of the operating system and the system. Read line reads one single line. Now remember, we're dealing with strings, so we need to convert it to an int, actually, not a float. We need it to be an integer. So after you've read the file information in, now you need to close the file. And this is important because your operating system, and this applies to all operating systems, can only allow so many files at a time to be opened. There's an actual limit of how much it can remember. So, we open the file, we read the line, and then we close the file. Okay? Now we are ready to look at the situation that this file doesn't exist. We need to create the combination and then write it to disk or save it to disk. And that's not that different from what we just did. So again, we're going to use file handle equals open. In fact, we're going to just copy what we have, because there's really only one change we're going to make in this line. The only difference between reading and writing is just an R to a W. And writing to a file is extremely easy. For that, we have the combination. We're going to use our file handle, and we're simply going to write. And then the combination. Now, when it comes to writing to the file, there is a little bit of a nuance that we need to be careful of. We need to write only strings. And thanks to the Python fstring method, we can actually do that very easily. Now, the curly braces are a part of fstring. You have to have them, as that denotes your variables. And a special thing for Python, and this really applies to a lot of different languages, if you want your text to start on a new line in a file, you need to tell the system that you've ended the current line. And that's what the \n is, or technically go to new line. So we've done that, and now we simply go through and close the file. So now, if the file doesn't exist, if the file does exist, we open it and we read the combination. If the file doesn't exist, we create it with a new combination. So let's see how well this is going to work. Now, we're only going to go with a very simple and quick process, and we have a bug. So what is our bug? Well, it's obviously going to be a typing error because it is exists with an S and not singular without the S. And we still are missing something. Okay, so let's go back into the file. And what did we miss? Well, OS has another layered directory. And that is, after you go into the OS library, it has a section underneath of it called path. That is a sub-library. Now, as you can see, this can get quite complicated. Now, you can simply abbreviate this as we did above with date time, but for now, because this is readable, we're going to leave it the way it is and see if it works. Okay, file handle close. We missed the dot. And that is on line 29. There we go. Okay, it found the combination and it took it some very infinitely tiny number. But now let's look at our folder and we see we have a new file called combination.txt. Let's display what it is. 318. Okay, that doesn't match the 68, so we have another bug. Let's try it again. This time it took 326 tries versus 586. So combination is wrong. But we're beginning to see how the tries are completely different over time. And that's important because as you test your algorithm in trading, you're going to be running simulations constantly against historical data. You want to be careful not to run it so much that you tune your algorithm only to the historical data where it fails in future data. But at the same time, this information can be used in a machine learning process to help hone in the algorithm such that it does better over time. So let's go back into our program and try to fix our bugs. Trial is completely messed up. So that's not doing what we think it should be doing. And that, of course, is the case in point of most programs as you write them. So if we look at our logic, trial is the index number of the list. So we really should be using guess and not trial. Because trial just says it was found at position 68 of the list. And even that may not be correct since it's deleting unused entries. So let's replace trial with guess. Now this was only a visual error, but it highlights the importance of constant testing, particularly when we get into the trading environment and little tiny mistakes start equaling real money. Never, ever take a trading algorithm into a live account without aggressively testing it. So let's try this again. Okay, now it tells us what the combination is, and it tells us how many tries it took and how long it took. And as you can see, if we repeat this process several times, 5 times. Now this is just randomly going through the list, no intelligence behind it. But it's easy to begin to see how you could actually build intelligence into the process to actually try to narrow down what the number is quicker. From the standpoint of trading, this is where your algorithms come in. Moving averages, Bollinger Bands, MACD, so forth. All of that begins to take place here. Analyzing and identifying how you want to make a purchase. So historical data is the stepping stone to going into a demo account, testing your theories and your equations, and then after the demo account has proved successful, then trying a small case live account. But you begin to see just how different what we think is from what the computer is actually seeing. And the thing about this is because we have the combination saved on file, we could actually run this simulation 1,000 times. Take the number of guesses and tries and then make an average of that, and that will give us a point of view of how frequently the program could find the number quickly versus more towards the outer edge of the higher numbers. And you'll begin to collect statistics on just how the program behaves. So through these trials, you can refine and perfect your approach. Now, the other thing that this highlights isn't just the simplicity of the file system, but it highlights the need of being able to store data on disk. That could be a list of trades and open orders. It will be your account ID and bearer token or password. So having such a simple process is a way of making sure that if your program is interrupted, it can pick up where it left off. We could actually extend this program using what we have right here and simply reloading this list if the program was interrupted. And every time we make a guess and we remove the number from the list, writing it to a file so that we're constantly updating the list of numbers we've tested versus not tested. And should the program be interrupted, it could actually be picked up where it left off. For the purposes of this program demonstrating the context of a hacker trying to break into a remote machine, that would be very much the case because they don't want to attack so aggressively that the remote host or remote machine begins to identify the attack. So they're liable to build a huge list of things to try, save that to a file, and then over the course of a week, a month, 6 months, or even a year, slowly try different things to see if they can break into the system. So security on both ends are going to be reading and writing files, watching from the attacker's side, did they succeed? From the victim's side, what's going on? Are we under attack and how can we stop it? So file management is critical in the world of trading, the world of security, or just in general. It's a very robust way of storing information, and we've only just touched the surface of what you can do. I could go into much greater examples, but I really think this is the best approach to showing you just how simple it is. And you have enough information with this to be able to repeat this process for loading the numbers list if the file exists on a hard drive, or creating the numbers list if the file doesn't exist. It's very easy to extend and expand this. So that might be something to tinker with between now and the next lesson. If you have any questions, be sure to leave me a comment below. Play with this, test it, see what you can do. How far can you take the concept? Because when we start to really take this to the next level, these simple 3 little lines for both reading and writing are going to be very important, because we're going to use them to write logs to files, meaning track what we're doing. Every byte and every cell is going to have a log or an entry that we can see it, because the whole goal of this program is at some point to run by itself. There won't be a screen connected to it. So you're going to need these 3 simple lines to actually convey information about what your program is doing once it starts running by itself. We could get into more complicated situations before we start writing our trading program, but we don't need to. And that's the biggest misconception about programming as a whole. You don't need to master the language to be able to write a program to complete a very specific goal. That's really what this series is about. Showing you how easy it is to go from knowing nothing at all to our next step, which is actually beginning to think about how we're going to trade automatically. Until next time.